Good morning, students. Today in this class, I'm going to discuss about common base, common emitter, and common collector configuration of a BJT transistor. First of all, BJT transistor introduction has been covered in the previous class. BJT simply is nothing but a bipolar junction transistor. Let's look into the first common base configuration. So this is a simple circuit of common base configuration for NPN transistor. Just look at the NPN transistor where the common base means where the base is common between input and output. See here the base is common between input and output. So input is always a forward bias and output is always in reverse bias for when you are operating the transistor in a active region, right? So only the transistor when you operate in the active region you will get a good amplification. So in this regard, let us see this NPN transistor where emitter is a negative. So negative is connected to the negative and the base is positive. It is connected to the positive terminal. So it becomes a forward bias and the output is always reverse bias. So base is connected to negative. That means base is positive. Positive is connected to negative and collector is also negative. So that means here we are going to the negative terminal is connected to the positive terminal of the battery. So, like if you look at this NPN transistor, here this is called NP, N, and that is a negative semiconductor, positive semiconductor, and negative semiconductor. So, together called NPN transistor. So, when you operate in the active region, so input is forward bias. That means the negative is connected to negative, and positive is connected to the positive. This is forward bias. Coming to the output, the negative is connected to positive. That means and positive is connected to negative. So, there is nothing but this is output. Okay. So this is how the common base configuration circuit goes. Here this is the input. Whatever the current IE is equal to IB plus IC. Right. While taking the input characteristics, that means between IE and the input characteristics IE and the voltage between base and emitter, nothing but VBE. And while taking this input characteristics, output voltage is constant. That is, voltage output voltage is between base and collector. That is VBC. So just look at the input characteristics here. You can observe the VCB is constant, and the characteristic between VBE and IE is plotted in this graph. You can observe this one. And if you see the curves VCB at 0 volts and 8 volts and 18 volts, you see the curve is shifting towards the origin. So this is for input characteristics. Now while studying the output characteristics between IC and VBC or VCB, whatever you take up. So here while studying the output characteristics or calculating output characteristics, input current is constant. That is IE is constant. So you see, if you see the output characteristics in the graph, you see, so the graph between VCE and IC. So here you see the IC is always in milliamps, current is always in milliamps, and voltage is in volts. So and input current is constant. Like if you see for 0 milliamps, 1 milliamp, 2 milliamp, 3, 4, 5, 6, like that. So the graph is shifting towards up. So this is what the common base configuration and this input and output characteristics. So the current gain is defined as output current by input current, and it is nothing but an alpha. So the current gain of a common base configuration is less than unity, typically around 0.98. This is about common base configuration. Coming to common emitter configuration, this is the most configuration used for the amplification, where here the emitter is common between input and output. So here the NPN transistor, if you can look at here, the base is what is the positive is connected to positive, and emitter, which is nothing but a negative, is connected to negative. So this becomes a forward bias in common emitter configuration, and output is in reverse bias. Let us see, the collector is connected to positive and emitter is negative. Here both are negative, but emitter is heavily doped. That's why you will always take as a negative. So that's why here you can see this is output is in the reverse bias by connecting emitter to the negative and collector to the positive. And coming to the input and output characteristics, while calculating the input characteristics, that means between IB and whatever the voltage between base and emitter, that is VBE, the output voltage is constant, that is VCE is constant. At the same time, when you're studying the output characteristics, that is between VCE and ICE, the input current IV is constant. So let's look at the graphical representation. That is what are the characteristics of input and output characteristics. So as you see the input characteristics here. So the graph is shifting from origin towards from origin to the wave. For example, if you see VC is equal to 0 volts, 10 volts, 20 volts. Here, the whatever the current, I mean, the graph between VBE and IB. So you can observe this is where the IB is in microamperes. So the voltage you can see linearly increase just like a forward bias of a PN junction diode. Coming to the reverse bias, you see this is between VCE and IC, and where the input current is constant. While studying output characteristics between VCE and IC, the input current is IB is constant. So again, the same, the graph shift from 0 to 120 microamperes. First 0 amperes, it is very close to the origin, but when it raises from 20, 40, 60 like that, you can see there is a gradual shift away from the center. So this is what the characteristics of common emitter configuration. And the current gain is termed as beta. Here the current gain is between the output current to the input current. The output current is IC and input current is IB. Here the current gain is very high. Normally, that's why the transistor used for particularly current common emitter is used for amplifying the current. So this is the most suitable configuration for the amplification. Next, coming to common collector configuration. So here this is a circuit for common collector and configuration. So if you look at this bottom figure, you can see the I mean always you can see the collector is a common between input and output. So that's why it is a common collector configuration, and emitter is in upward direction. So the base positive is connected to positive and the collector is connected to negative. This is what input and output. If you see the emitter is always negative, as I already told, it is highly doped, and the collector is connected to positive, so that it is nothing but an output configuration. So during input configuration, during input characteristics between IB and whatever VBC, the output voltage VEC is constant. And at the same time, when you're studying the output characteristics between VEC and IE, the input current IB is constant. Just look at the input characteristics. So the graph again shifts from origin to away when the voltage is increased in the common, that is output voltage is increased. So the graph shifts like that. So this is the voltage, this is the curve between, this is the characteristic between VBC and IB. So where VEC constant, so you can observe the graph. At the same time, this is the same common for all common emitter or common collector, common base configuration. So where here the output current is constant, 0, 20, 30, like that up to 120 microamperes has been studied. You can see constant shift from origin towards the maximum as you increase the input current. So the output voltage, output characteristics between VEC and this is a VEC and IE. So this is what output characteristics. So this is how we can calculate the input and output characteristics. And the current gain we denote it as gamma. This is nothing but output current IE by the input current IB. So here the current gain of a collector amplifier is also high. The current gain of a collector amplifier is also high. Thank you. Thank you.